this part of the system is a pressure force main. So these are just junctions where it turns. These could be air release valves, and maybe that makes an easier way to grasp it. So in an air release valve situation, you would have a manhole with a rim and an invert. Okay. You need to have junctions if you're tying other flows together, so on and so forth. So let me take these up. 105. Let's just go really far. 150, and then 155. I'm going to connect those junctions now with the pipe. So note here you can do a pipe with different bends at it. But you'd say, well, why would I need this junction then? Well, if you're going to bring another piece of the system into here, into this force main to connect up, you're going to need, you can't connect pipe to pipe directly. So even if there's an air release valve there or not, you need to have a node. But if you do need to edit the bends, these selectors over here, there's an edit vertices, so you can select the pipe and then you can drag those to move them around. You can even add vertices, delete vertices, things like that. Final piece here is we do need an exit, so this would be sort of your treatment plant or whatnot. We're going to make a connection there. Do need to go into these pipes, change them from circular 18 inches. We're going to do a 2-inch force main. Okay, do the next. And we're at 150 here, so then let's drop down. Let's say this is just an outfall. It goes into a manhole there, and then from that manhole directly gravity flows into the pump station. So let's say it's a 12-inch pipe. Culvert, it's 150, and then let's say it's 149. For the outlet, and then this final free fall, 145, and then your type of outfall. Is it free? Is it normal? So on and so forth. We've had that a part of hydroflow for a while. One thing we do need to do on this pipe is, how do we represent that there's a check valve in the system? So this flow, when it's pumping up, it can't just flow back down into the wet well. If you right-click, or if you double-click on one of the pressure lines, so this would be the first line coming up, and you want to simulate a check valve in the system, use this flat gate, you check that on. And that forces flow to go in one direction. Otherwise, it can go bidirectional. At this point, I think everything's set up. Let's take a look at what we've created here. And let me save this. Save it to class. And you can, there's some other options over here. You can do a profile plot. So I click that profile plot. I can pick my upstream node and then my downstream. It's going to generate a profile for me. I can take a look at this. So you can see that's our system. We're coming down here from the home. We're coming down into the lift station. After the lift station, we pump up, and we have pressure lines coming up here to the top, and then it just gravities down into the treatment plant. So everything looks good geometry-wise. Some options you need to set in your system for analysis of this. You have to give me a second here. Project options. You go into, sorry about that, go in design, then project options. You know, gallons per minute. Hydrology method, there's that SWMM. Important piece down here is that when you are doing low pressure system design, you have to set this to hydrodynamic. If you have it set to kinetic wave or steady state, that's going to just it's not going to let flow go both ways, and it just won't run the model. Here we talked about the Hayes and Williams, and that's what we used. There's also the Darcy-Weisbach for force main equation for when it gets pressurized. So that sets that up. The next piece is going to our analysis options. The routing is important. The routing is essentially how it's going to calculate time step. So it's going to, every second it's going to calculate a time step point. If you're using hydrodynamic, you have to have this value less than 10 seconds. They recommend even less than 5. I just set it to a second. It doesn't take that long for the computer to, go through the analysis. And then the report, 5 minutes. I had it down to a minute or 5 minutes. So it's calculating based on every second, but your report units will only be down every 5 minutes. And of course, if you've had a combined system, this would be the hydrology part. This would be the sanitary part. It asks you for actually calendar days when you're going to run this. So if you want to do a 24-hour period, you would just pick a next day. I just make January 1st to January 2nd typically, but essentially this is your analysis duration. You can have your report dates actually start and end different from your analysis. Hydraulic flow routing, have that checked on, of course. If you don't, it's not going to do anything. I'm not going to go into these variables. I would suggest everybody looks in the help for these and the length, time step. I would leave these at 0 unless you have some other good reason. I'm going to click OK. Our analysis should be good at this point, and we're just going to run it. You can go back up to analysis and perform analysis. It goes through and does a simulation on it. It will save a little report. I usually just uncheck that. This is an important, talks about some of the error. From what I've read, if that gets above 10%, you need to worry. Your model's not right. Hit OK, and now we can look at the system. And I'm going to look at the profile again. And turn off some of this stuff. Go back in here. Oh, I don't need all this text. All right. So essentially what you see on the screen here is your hydraulic grade line. If you go up to the output, you can run a custom report. You can look at the ASCII output report. Essentially, is its raw report. Important thing to look down there is the water surface, the warnings and error messages. There's in the help. It talks about each one of these and what you might need to do. So you can see we have a number of problems we need to look at. And we'll get to those here in just a second. Go back to my profile tab here, what has the profile made. You can also go up to output and hit the output animation. And essentially you can watch the system work. So in this scenario, we got water flowing into the pump station. Water surface elevation starts to rise. Pumps kick on, it drops back down again. And that's essentially your system. I mean, low pressure system, that's what you're modeling. Imagine that with a bunch of pumps, not just one. You can see some things are a little goofy here. Why don't we have data over here for max velocities and so on and so forth? Well, looks like everything's working right, doesn't it? But it's not. You can't ignore those error messages. Those meant something. What is going on there is that we're restricting the model. This took me a while to figure this out. When you're doing a pressure system model, you have to not restrict that hydraulic grade line. So by restricting that leaving that at 0, it means essentially the hydraulic grade line is set at the invert of the pipe. So when the pumps turn on, there's an immediate loss of water. So the rest of the system never sees any water. So the pumps turn on, it goes into that first pipe, and it disappears because my surcharge elevation was 0, which by default it will bring it up to 100. So I need to make that some ridiculously high number. 10,000 seems pretty high and ridiculous to me. We'll go with that. And I need to set that at every node. Now, if you were doing a conveyance design, yeah, you wouldn't set that at some ridiculously high number. You would set that at the top of your manhole. And then if your hydraulic grade line gets up to that, it's going to say submergence, going to give you error warnings. You know you need to fix something because you can't submerge your inlets. Close again, and we should be good. And go ahead and run this one more time. Hit OK. Come back here. And then you can run your system again. You can see now we're getting velocities. Getting velocities down here from max velocity in our force main, so 4 feet per second, not too bad. And go from there. Some of the things you can do for just this display, this means there's some things we need to look at with these pipe. Display options, you can go into options here. You can actually, I just did a right click on the desk on the screen here. This is where you turn on, what text it shows on the screen, so on and so forth. You can set these to flow velocity, turn on my legend, turn on my 2 nodes, and then you can actually see it will color code the system. Notice you can keep that time thing running and toggle in between your profile and your plan view. And then down here you can actually look at your time series plots. All these reports and graphs, this is where this customized report is. You can do some output. You can output to Excel file, so on and so forth. You can, all these things you can look at. Exfiltration, volume, flooding, so on and so forth. There's a whole thing in reports. That's essentially it. That's the crash course on low pressure system. If you think about it, there's really not too much you can't model with this. I'm drawing a blank on what we do that you can't model with this. It does all the nutrient stuff. It does all the sanitary stuff if you have combined systems, or you're just doing gravity and pump stations for the sanitary side. If you're doing storm and have ponds and weirs and culverts, and it goes out of your system into a channel and then under a road culvert, then back into an inlet, and then goes off to your bit, you can put that all right in here and just run it all at once. So it's an option. So that's it. I'm just going to leave here. I'm going to show you the little light show that this thing does when you have a lot of little things coming together on it. So as you can see now, I have time lapse. So these, this is count through minutes like seconds, even milliseconds. You can see when the system's actuating and pumps all these different things are pumps turning on, and so on and so forth. And then you can go in your time series plots, and you can see if I look at, come down to links, and I come down to what do I want to look at? Head point. So this is the head on the pipe. So that's total dynamic head. So that has to do with elevation and all the pressure in the system. And that's right at this point, right here, where the shopping center pumps in. You can see how that head value, as you go into your 8 o'clock, 10 o'clock hour, because there's so many pumps turning on at the same time, that head starts to increase. And some of the things we're trying to pull away from here is that the shutoff head for that pump for this station right here. So the head elevation where it can't pump past it, it basically will turn on but no flow goes out because it's too much pressure to push against, is 146. So we are right at it for that, and it's a private pump station, and here we're above it. So at this part, it's this time in the system when that development's pump station turns on, no water comes out, and that wears on the impellers on the pump, and the pumps will start to wear out.